Okay, everybody, welcome back. So this is the video for the velocity versus time graph. All right. What we want to do is we want to be graphing the velocity on the y-axis just like we did the displacement in the first graph. So I'm going to create a new column in my worksheet here, and we're going to call it velocity, which we know is measured in meters per second. Now do be careful because when you write down your uh, displacements, they do need to be in meters, otherwise your velocity is not going to be in meters per second. So how do we get these velocities? All right, that's kind of the problem that we're looking into here. So the velocities are going to come from our ramp here, but there's not a great way to measure them. All right, the graph that we're trying to make looks like this. We have velocity on the y-axis in meters per second, and we have the time on the x-axis, which is in seconds. As the marble rolls down the ramp, it's going to start up here, and when it starts, it's going to have an initial velocity of 0 meters per second. It's going to roll down the ramp, and when it reaches the bottom, it's going to have some final velocity. This is what we're trying to graph in our velocity versus time graph. To do this, though, we actually really need to calculate it. All right, there's no way to measure this velocity directly, so we're going to have to calculate it instead. We have two other values for this. We know the displacement, right? Maybe in this example, it's 10.0 centimeters, which we know is 0.100 meters whenever we're doing it in meters. The other thing we know is the time that we get for the experimental part. So maybe we have a time for this of, I don't know, let's call it 1.2 seconds. So based on our givens and our one unknown, we should be able to find that final velocity. We just need an equation that's going to match that. So what equation does match that? Well, it's this one. Delta x is 1/2 times v plus v naught times delta t. All right. For us to be able to do this calculation, we could do this 30 times, but I want you to really think about that. That's going to take a whole lot of time to be able to do that. All right. We're going to do this same calculation in the exact same way a bunch of times. So let's rearrange this, and then I'll show you how to program this into Sheets so that it'll do the calculations for you. The first step, though, is that we want to solve for v. But I'm going to do something a little bit sneaky here. All right. Since my initial velocity is 0 meters per second, I know that that's going to be 0. V plus 0 is just going to be v. So this actually simplifies a little bit to 1/2 times v times delta t. So that really makes it a little bit easier to rearrange. Now I'm going to take care of the 1/2 by multiplying by 2. That gives me 2 delta x is equal to v delta t. And now I can divide both sides by delta t, just like so, and that gives me v. So now I have an equation for the final velocity at the bottom of this ramp. And that's what we're graphing up on this axis. So we have 2 delta x over delta t. So this isn't the worst calculation to do, even 30 times, but we're going to see just how fast this happens if I use what Sheets can do and actually program this to do the calculation for me. Since I have my equation, what I'm going to do is I know that I want to take 2 times the displacement and then divide it by the time, and that should be the velocity each time. So let me go back to my sheet here. So my velocity in meters per second should be equal to 2 times my displacement divided by my time. Right? That's what it says here. 2 times the displacement divided by the time. So I'm going to do equals the number 2 times the displacement. So I'm going to click on my displacement cell. Divided by the time, which is this cell. So it's 2 times b2 times it divided by a2, and this should give me the final velocity, which in this case is 1. Well, rather than type that in all those times, I can click and drag, and bam, I am done with my calculation, right? So these are all of my final velocities. And I did it just that quickly. The next step, though, is to create our velocity versus time graph. All right. So I'm going to do velocity and time, and I'm going to select those two. I'm going to insert my chart, which, right, we want to get this not a column chart. We want our scatter chart. And look at that, right? So this is our velocity versus time graph, right? So if we look right along here, all of our velocities are on the vertical axis, all of our times are on the horizontal axis, right? And now from this, I can enter or put on my trend line, right? We're going to want to add all of the labels for our axes and the labels for the total graph, but here's where it is. So we have an equation now. Now look at how this works out. The displacement versus time graph was a quadratic, but this one is really linear. All right, and we're going to see that this matches with an equation that we've used before too. All right, so I see a pretty good correlation here again. I expect you guys to get another good correlation, but this is my equation. 2 times x plus this. So this is my y equals mx plus b. So let's go back and look at that for a second. All right. So how do I get my acceleration from this graph? All right. These calculations are all done. I'm not going to use these equations again. That just helped me find my velocities so that I could graph them. All right. But now on my graph, I have a y equals mx plus b. What am I going to do with it? And what equation is it giving me? All right. So my data looks something like this. I have a linear graph, y equals mx plus b. Well, this matches up with another equation that we've used as well. This matches up with that the velocity is equal to v naught plus a times delta t. All right. So in this equation, right, this is my final velocity right here. That's my y values right up here. These match, right? This v naught, that's my b value. So that makes my acceleration on this graph, so when I get this value off of here, my acceleration is whatever comes in front of my x, all right? Because t is my x variable. So what did I get? All right, what was on that graph? It was 2x plus 0.323. So the equation was 2x plus 0.023 or something like that, right? So what's my acceleration? Well, I can get it right off of it. It's the slope of this graph, all right? That's the acceleration. It's the slope on the velocity versus time graph. And that's because it matches up with this equation, our kinematics equation, all right? So we don't have any calculations to do at all. This is giving us the slope. This means that the acceleration based on my graph is just 2 meters per second squared. Now I can take that and I can compare it to what I got on my first graph. And so I have my two accelerations. Now I want to compare these two things together. They shouldn't be the same value, or they probably won't be the same value. So how do we compare two things? We don't know which one is correct, so how do we do that? But this is how we make our velocity versus time graph. This is how we get Sheets to actually do that calculation for us. And what's the next step? All right, so the next video is the final step.